First of all, I would like to thank Natalie and Klaus for inviting me to the symposium. And today I would like to talk about understanding social motivation and neuro-pharmacological and clinical account. So let's start with a very broad definition of what is social motivation. So social motivation refers to the process that initiates, guides, and maintains behavior that are oriented to consume social rewards. And as for any other type of rewarding stimulus, an intact motivational system is fundamental for health and well-being. In the specific case of social motivation, for example, it has been hypothesized that a reduction in interest to approach and consume social rewards being at the core of the deficit of the features that are present in autism spectrum disorder. For this reason, in the last year, a growing interest to understand how social motivation works has been observed. In the specific case, and in this talk, I would like to stress that to understand social motivation is important to study in the broader context of reward process in general. And over the last decades, I think beautiful research in animals have shown that we could distinguish different discrete neurobiological and neurochemical components of reward processing. For example, we can talk about wanting, that is a process or component that is present during the anticipation of a rewarding stimuli and being regulated mainly by dopaminergic activity together with opioidergic activity in the brain. A second component that is liking, that is happening or taking place during the consumption of the rewards, and it refers to the hedonic pleasure that we receive by consuming such rewards, and has been shown to be mainly regulated by opioidergic, among other neurochemical compounds in the brain, endocannabinoids, and so on. And a third component that is learning, so what actually promotes us to repeat a behavior to approach the reward. And in the specific case of social motivation, I believe that it is important to characterize how wanting of social rewards and whether it differs from liking of social rewards. A second fundamental element is also to understand how social and non-social rewards differ from each other at the neurobiological and neurochemical level. So this is the goal that I have aimed in two different studies, a pharmacological study and a clinical fMRI study that today I'm going to present. The first study was aimed at causally manipulated dopaminergic and opioidergic system to test for different neurochemical regulation of wanting and liking and to test for different neurochemical regulation of social and non-social rewards. And this question was followed up by the clinical fMRI study to investigate whether neurotypical and neurodiverse individuals, namely autistic spectrum disorder participants, they show differences in social and non-social reward processing, and if these differences are more stronger for wanting compared to liking. So in order to do that, we developed together with Sebastian Korber a paradigm, a new paradigm with a high translational value, namely it was strongly or heavily inspired by animal research, in which we perform a within-subject design and primary tangible social and non-social rewards of similar magnitude were both anticipated and consumed at every trial. And together with an explicit measure of wanting and liking, so subjective wanting and liking, we also collect measure that more implicit measure that resemble the one that are usually used in animal research. The goal was here to operationalize reward processing and particularly reward liking and wanting in a way that is similar to animal research to see whether pharmacological challenges or clinical condition have an effect on these two elements. How the stimuli look like. So basically we use for non-social rewards food stimuli. That is usually what is used in animal research. So participants, they receive different concentration of chocolate milk to create different reward levels that they were delivered with a computer control pump. And to recreate a similar or comparable tangible social reward, we use touch. Also touch and playing, grooming are a very dominant element in animal research. And specifically for humans, we use caresses on the forearm with 3 different speeds. And we know from past literature that these speeds are able to elicit a different level of pleasantness, with the slowest tactile sensation being the one most preferred. After the delivery, or after the anticipation of these rewards and the delivery, we gather several measures of wanting and liking. And apart from, as I say before, subjective self-report, we also ask participants to press a hand anemometer in order to receive the reward. And also we collect facial muscular expression, so facial muscular activity, resembling the hedonic orofacial expression used in animal research to map hedonic anticipation and hedonic consumption. So the idea was to use corrugator and zygomaticus activity to map increase or decrease of pleasant sensation. The trial was looking like this. So it was a very, very simple trial. First, the rewards was anticipated, either food or touch. Subjects were asked to rate how much they wanted the stimulus and to produce effort in order to obtain the announced rewards. And the stronger the force applied, the higher was the probability to receive what it was announced. Then they were rewarded with the reward if they had pressed enough. Otherwise, they were rewarded with a less preferred options. They prepare for receiving the rewards. The rewards was delivered, so either the chocolate milk or the caresses, followed by a relaxed period and the rating of subjective liking, so how much they liked the stimulus they just received. And along the entire trial, there were facial EMG was recorded. So in the pharmacological study, we enroll 131 participants. You can see here the mean age and standard deviation. And it was a between subject drug design in which 40 participants were assigned to the amisulpiride group. So they receive D2, D3 dopamine blocker receptor antagonist. 44 they receive an opioidergic antagonist, naltrexone, and 45 a placebo drug. And then they perform the task that I just described. So what we observe, so we first look at the subjective measures, so the subjective wanting and liking, and in this case, we did not observe differences between the 3 groups. So in the graph on the upper and lower line, you can see basically amisulpiride, naltrexone, and placebo for wanting and liking. And as you can see, there is a clear differentiation between high and low reward stimuli that is similar for social and non-social reward, but there is no group difference. So the 3 groups they were reporting to liking and wanting the stimulus in a similar way. What was more interesting for us is the fact that we observe instead a difference in the effort produced to obtain the reward. Indeed, the amisulpiride and naltrexone groups, compared to the placebo, they produce much less efforts to receive food rewards, while this was not observed in the control group and was also not observed for the touch condition. This reduction of effort was nicely mirrored by corrugator activity during anticipation, in that for the amisulpiride and naltrexone group, we observe increased corrugator for food rewards compared to placebo and also compared to the touch condition. And corrugator activity or increased corrugator activity usually is associated with increased dysplasia. So this reduced effort seems to be mirrored by an increase an increased dysplasia in facial expression. A second interesting finding is that during the consumption of the reward, so when they had to drink the chocolate milk or when they received the caresses, only the naltrexone group was showing a different effect. So namely amisulpiride and placebo, they show an increase of zygomaticus activity the more they reported to like the reward, but this association between facial expression and subjective feeling was disrupted in the naltrexone group. So what we can infer by this first study is that there is a partially different neurochemical regulation of wanting and liking of rewards, namely that both naltrexone and amisulpiride, so dopamine and opioid antagonism, acts on the anticipation of the rewards, while only naltrexone has an effect on the consumption of the rewards. And this is in line with animal model of reward processing. And secondly, what we observe is that there is a partially different neurochemical regulation of social and non-social rewards. Indeed, the effect in anticipation were exclusively limited to rewards of non-social nature. And this could point toward the possibility of two separate systems that process this type of rewards. So now let's move to the clinical fMRI study. So in this case, we investigate neurodiverse population and we ask similar question whether the wanting and liking of rewards is differently impaired or processed, and whether this is more or stronger for rewards of social nature, as the social motivation theory would suggest. In order to do that, we enroll 24 autistic participants and 25 neurotypical participants, and we use the paradigm that I described before, this time in the scanner. But as previously, we gather both subjective rating and more implicit measure of wanting and liking, namely effort and facial EMG. So the results point to no difference between the two groups. So namely for wanting, the effort and liking, they are the three panel that you can see in the slide. Both autistic individual and neurotypical were able to differentiate between high and low reward equally for food and social. So we did not see, so we see the usual effect of reward level, but we did not see any group difference. What was interesting to observe is that difference emerge when we look at facial EMG. So basically the implicit hedonic, anticipatory, and consummatory reaction. Indeed, what we observe in this case is that both in anticipation of the reward and in consumption of the rewards, while control subjects for the corrugator show a decrease of activity the more they wanted and the more they liked the rewards, this relationship was either revert or absent for the autistic subject. So suggesting that probably what we have here is a normal reflection, a subjective reflection on the processing of rewards, but where we go to implicit measure, some difference between groups emerge. So to conclude the fMRI, the clinical fMRI study, we could say that no difference in subjective wanting, liking, and effort to obtain social and non-social rewards was observed. And this actually is already in line with most recent literature that suggests an intact subjective response to touch, for example. And also points to the fact that also at least the subjective motivational system seems to be not altered. But what is altered or different are the anticipatory and consumatory hedonic facial responses in the autistic subject compared to the neurotypical population. And therefore, we can hypothesize an atypical processing and association between subjective experience and facial activity or facial expression. So what we are looking now are possible differences at the neural level, and this is what we will work on in the next months. So, and then with that, I would like to conclude and to thank Sebastian, Claudia, and Emilio that helped in the preparation and collection of the data. So without them, all this study could not be possible. I would like to thank the autistic population that took part, and all the subjects took part to our experiment, and you for your attention, and I'm looking forward to your questions.